Okay. All right, so it's set up. Let's give it a minute and we will start in a few. It looks like not all of us are here yet.
Oh.
All right. Okay, so we are still missing a few people, but this is recording so they can watch it later if they are not here. Today, guys, we're going to have a pretty short lesson. So what we're going to do is we're going to review, we're going to do another instantaneous rate of change problem. And we're also going to take that a little bit further. So remember how the instantaneous rate of change, another way I could have asked that question is to ask for the slope of the tangent line. And those were synonymous. And so I want to do the instantaneous rate of change. I want to get that slope of a tangent line. And anytime we have the slope of a line, we could find the equation of a line. So sometimes it's important for us. Let me draw. So remember what the tangent line is. So we have some function. And I know I've been using squared functions, but remember these functions could look like anything. So let's say we have some function in the plane and I pick a point. So remember for instantaneous rate of change, I do need to pick a point that we called A. So let's say I pick this point right here. And I ask for the instantaneous rate of change. But remember another way I could ask is to say, let's find the slope of the tangent line at that point. So you guys, here's the tangent line at that point. Remember, it's that straight line. It's going in the general direction that the function's going at that point, but it is a straight line. And the place that it touches the function is at that one spot. Okay, so that's the tangent line. I know that my calculation gives me not the equation of that line, just the slope of that line. It just says how it's increasing or decreasing. But because it's a line and it's in the plane, I could find the actual equation of this entire line, because even though we draw a little bit of it, it is a straight line that goes on forever. So we're going to talk about that. And then we're going to work around our problem. Remember our problem with instantaneous rate of change is that I pick a point, I do that big calculation, taking the limit of that formula and everything for this particular point, and I get that one slope of that one tangent line. But if I wanted to move even just a little bit and talk about the slope of the tangent line at this point, I would have to do the whole thing over again with a different value for A. And you guys, that can be really time consuming. And we do have a way around that. But first, I want to stick with what we're doing, finding the slope of this line and the equation of this line at a certain point. So let's get started on that. I'm going to make a function. let's say I've got f of x equals 3x squared minus 4x plus 1. So that's the function I want to work with. I do want to find the slope of the tangent line or the instantaneous rate of change. For this function, at the point where, remember, I could say x equals, or I could just say a equals. Either way, this value that I give you is your a. So let's say I want to know what the slope of the tangent line is at x equals 1. Okay, so instantaneous rate of change. Let's remember what your formula looks like. So remember, it is a limit calculation. So we have to start with the limit as h approaches 0. And then remember, we have something on top, something on bottom here. On top, we have f of a plus h minus f of a, and that's all over h. So you guys, this is our formula. We use it every time we're doing instantaneous rate of change. The more you write it down, the more you will remember it. And then let's fill in what we know. So you guys, all that I know so far is that my a value here is going to be a 1. So let's put that in there. So I have the limit as h approaches 0 of f of 1 plus h minus f of 1 over h. So I've got that put in. Now, what's our next step? So you guys, in your next step, you want to find f of 1 plus h and f of 1. So you can put those up there. So let's do that. Finding f of 1 is going to be pretty easy, right? Finding f of 1 plus h is usually a little bit more difficult. I'm going to make sure you guys have this written down before I erase and I can move on. So I'm sure you've got that. You probably have.
I'm sorry,
that.
I think I came in a little bit late. Where did the 1
so
come?
leave that line and let's continue. Okay,
Hello?
good. Let's find f of 1 plus h. I don't know why I put an equals there because this is side work. We'll do that. All right, guys, so this is work on the side. This is finding f of 1 plus h, so I can put it here into my formula. So we had 3 times x squared. So remember, in the x, we've got 3 times 1 plus h. That's what we're putting in for x squared. Then we had minus 4 times x again, so that's where we put the 1 plus h. And we had a plus 1. Oh, sorry guys, I got this in that weird glare area. That's a 3 times 1 plus h squared. All right, before you deal with the 3, hold on, I can't hear anything. Let me see. Let me figure out why. Oh, you guys, I was muted. Okay, I'm not muted anymore, so if you have questions, I can actually hear you ask them now. I'm sorry. I just thought you guys were all just silently, listening and understanding. Okay, so you guys, let's keep the 3 there. But let's do the 1 plus h squared. Remember, this is the important part. This is the part that's going to make or break your problem. You have to remember that this is 1 plus h times 1 plus h. Now here, because it's not squared or anything, you can go ahead and distribute this 4 to both of these terms. And you can call this minus 4 minus 4h plus 1. Let's FOIL this out. So here I've got a 3, 1 times 1 is 1. 1 times h is just h. We have another 1 times h, so that's another h, and then h times h is h squared. Here, if you want, you could put the -4 and the +1 together. We could call this minus 4h minus 3. So we've gotten those taken care of. All right, so I want to put these two h's together. Now, if you want to, you could put these two h's together as 2h and distribute this 3 at the same time. I'm just taking it seriously, one small step at a time. So this is going to be 1 plus 2h plus h squared, and I have not distributed the 3 yet, minus 4h minus 3. So next step would be to distribute this 3 to all 3 of these terms in here. So I have 3 plus 6h plus 3h squared minus 4h minus 3. And then let's combine like terms. So I have a 3 and a minus 3. So what's going to happen to those 3's? I'm just not going to have a constant, right? It's going to zero out. So those are gone, but I have plus 6h minus 4h. So that leaves me with 2 h's. And I have the plus 3h squared. All right, so that's what I got here. This is, remember, 1 plus 8. So all of this just gave us that one little piece. We still have to put that into the equation. All right, let's find f of 1. Remember, putting just a 1 into our function, we're going to have 3 times 1 squared minus 4 times 1 plus 1. I know how this should work out. So this is just going to be 3 minus 4 plus 1. What do we get there? Big 0, right? Because we have negative 1 plus 1. And you guys, if you've noticed anything about working these problems, one thing you will notice, or you will come to notice, is that whatever you get for this value, f of 1 in this case, or f of a, it's just a number, right? And when you end up putting it into your formula, it will cancel, it always cancels out. So the fact that this is a 0 makes sense because notice I don't have a constant down here to cancel it out. So I don't, what was it? I can't remember what the number was in the last one we did, but we got a number here, and then it also showed up here. So when I subtracted, that number went away, and that should always happen. So in this case, there's no number, or this is 0, and this was 0 too. So it's still working. It's just that that number, I guess it took care of itself. But anyway, so we have f of 1 is 0, and we have f of 1 plus h. It's this right here, this 2h plus 3 squared. So before I erase that so I don't forget it, let's go back to what we're looking for. Remember, we're looking for the limit as of, now right here is f of 1 plus h, but I already found that, and it's right here. So instead of writing, I lost something. I think it's the square there. So instead of writing f of 1 plus h again, I'm going to write this, because that's what I found. So I'm going to have the 2h plus 3h squared. Now, remember here, it's minus f of 1. I found f of 1 is 0, so I get a minus 0, or you don't even have to write that because it's 0. And then we do have the h on the bottom. Okay, so let's see what we can do next. So we haven't taken the limit yet, so we're still writing limit as h approaches 0 of just this, basically, because you don't need to write that minus 0. But what can we do now? since this is really gone, what's my next step? Do you remember? So remember, my goal is to take the limit, but I can't take the limit. I can't put a 0 in for h if I have an h down here. So what do I want to do? Yeah, so I want to take h out of everything is what I want to do. So yes, I'm going to take a factor of h out of every term because each of them have an h. Remember, you can't do that step until you're here where all of your terms on top all have an h in them. But we are here, so we take a factor of h out of everything. What happens is what we're left with is going to be this 2h just turns into a 2. The 3h squared becomes 3h. And on the bottom, that just becomes a 1, so we don't even have to write a denominator at all. Okay, so now can I take the limit? Yes, I can. So I can do the limit as h of, wait, I'm taking the limit, guys. This is the line I get to drop the limit calculation, right? Because I am taking the limit, but how do I take the limit? So kind of, so in not solving for h necessarily, but I'm plugging this value in for h. Yeah, so I'm plugging it in. I want h to approach 0. So to take that limit as h approaches 0, you actually put a 0 in for this h. So when I do put a 0 there, what happens is that whole term goes away, right? So what am I left with? Just a 2? Yeah, just a 2. So all that for a 2. But what does this 2 represent? Well, it represents the instantaneous rate of change at the point where x equals 1. It also represents the slope of the tangent line at that point. So if 2 is your slope, you guys might want to make sure you're muted if you're not. You'd be surprised at how loud background sounds sound. So anyway, so 2 is the slope of that tangent line. But I said I wanted to take this a little further, and I do. I don't want to just know the slope of the tangent line. I want to know the equation of the tangent line. So let's think about algebra. What do I need to make a line? What information do I need to write the equation of a line? Let's okay, why do we have to put the 2 as a power outside the parentheses?
Okay, that was my question. So
okay.
Are you putting that as a power because you like put it up into like the right on that parentheses, that 0 with like an arrow, or are you just saying you canceled it out and it's now a 0?
I just took this term and it became 0.
Okay. I thought you put it as a power and I was like, why was that there?
Yes, I'm taking everything to the 0 power.
Okay, thank you.
Okay, cool. All right, so we need a specific set of information to make the equation for a line. It depends on what form you're using. We're most used to slope-intercept form, right? The y equals mx plus b, but I don't have enough information in this case to use slope-intercept form. So if you're in algebra, say you're in algebra and you're making a bunch of line equations, and the problem doesn't give you the slope and the intercept, your next best thing is to use point slope form. And that's what we'll be using here. And don't worry if this all sounds like gibberish because you don't remember doing that in algebra. We will go through it slowly. I have the slope, but to use point slope form, I need a point on the line. But you guys, we're in luck because we actually already found a point on the line. So tell me, I just put x equals 1 into my function and I got an output of 0. Can you see the point on the line that I already found? So I think 1, 0 is a point on my line. Now you might say, wait, that's not a point on your line, that's a point on that function. And those are two different things. You guys, why do I know that this point is actually also a point on my tangent line? Well, remember, I've got a function and I pick the point where I want to draw the tangent line and then I draw the tangent line. Remember, they share that point, the one that you picked. So when I said as x equals 1, that guarantees that your tangent line goes through that exact same point. Remember, that's the only point that the function and the line share. And we just happen to already calculate that. So you guys, this isn't a far stretch from, there's not a lot of extra work to do because we do all this work just to find the slope of this tangent line. And in doing that work, whatever this f of a is in your output, that's going to be the point on the line that you do use. So I have the slope is 2. I also have a point on the line. So I use point slope form or a version of that. I actually use a version of that. And I'm going to show you how I do it because I think it's a little bit easier. So here's what I do, and it is a version of point slope form, but we're actually going to, we're going to we're going to kind of like fake use slope intercept form. And the reason for this being is y equals mx plus b is something we all remember. You know, you just always remember that, y equals mx plus b. So because it's something we remember, I want to be able to use it. So let me show you how I'm going to find the equation for this line. So I'm going to write down slope-intercept form. I don't have enough information for this. But using what I know about point slope, what if I put in all the things I do know? So first of all, you know the slope, right? And you know that m equals the slope in this form. So let's start there. The slope was 2. So y equals 2x plus b. Problem here, I don't know what b is. That's the problem. Because remember, in the equation for a line, you're going to have an x and a y. What you're not going to have is just a b. That's going to be a number. I don't know that number because I don't know the y-intercept. But using this point that you do know is on the line, do you think that I could take this x and y value, put it into this equation here for x and y, and solve for b? Absolutely. And you guys, that's the easiest way to get the equation of a line when you have a slope and a point. So let's do that. I have the 1, 0. I will say just be careful here because your point as it's written, you know x comes first. So x is 1, y is 0. But when you're subbing it in here, y is the first one. So just make sure you don't get them flipped around. So y is 0. So I put 0 equals 2 times x. This is where you put in your x value. So I get 2 times 1 plus b. You're not going to put anything in for b because we're solving for that. So I get 0 equals 2 plus b. I'm trying to isolate the b, so let's subtract the 2 from both sides. So I get negative 2 equals b. You guys, if b equals negative 2, I now have everything I need to write the equation for this line. So b equals negative 2. I already knew m, or the slope, equals positive 2. So the equation for this line is y equals 2x minus 2, mx plus b, and our b was negative 2. So let's talk about what we found. we had a function. We picked a point on that function at x equals 1 or a equals 1. We calculated what we call the instantaneous rate of change. What that gave us was this slope here. And then we used this slope and a point we had already found from the line, and we found the equation for the tangent line. So let me draw a picture of what we found. It's not going to be super accurate because I'm not going to take that function and, graph it perfectly. I'm just going to, sketch. Whatever that function looks like, guys, it's a parabola. So we have a parabola. I picked a point at x equals 1, remember? So let's say that's here. So this was a point at x equals 1. And I picked that point and I said, hey, I really want to make a tangent line here. So I did. And then I used instantaneous rate of change formula to tell me that the slope of this tangent line is 2. And then from there, I used that point at 1. And remember, we found out that when x is 1 here, that y was 0. So I put in that point 1, 0, and I found more than just the slope of this line. I found the actual equation for this line. And that, I don't know, looks pretty close to me. Looks like about a slope of 2. But that's what we found. And I know that might not seem like something important to find, like, okay, well, great. We got a line equation. But you guys, it is important. And we're going to keep going with this tangent line stuff. Let me see. We're going to keep going with it, but we're going to do it next time. I'm still going to let you stew in the fact that we have to do this calculation for every single point that we want to know. I promise it will get better, and this will all make sense. But right now, I just want to make sure that you can actually do the instantaneous rate of change, because you do have some homework questions about it. I want to say that I put a question like this on there where you have to find the whole equation, but I'm not sure. I might not have. This might be an extra thing. But I do want you to know how to do that. Go back to your algebra roots and remember some things about lines. But yeah, guys, other than that, other than the extra practice with the instantaneous, I don't want to move on from there yet. I will on Friday when we're in person, but that's really it's an in-person lesson, if that makes sense. Steps. Ooh, like steps. Okay, I think I know what you mean. So, step by step, you guys. So basically the steps that I said there, but, so let's see, let's call this, tangent line calculation. All right, so steps for a tangent line calculation. First of all, you would, let's see, I guess you would write out the instantaneous rate of change formula. With A equals, well, A would equal whatever your value in there. So let's just say with A equals a number that would signify putting in that value for A. And then from there, the step 2, I would say you really need to find f of A plus h. And we'll go ahead and say also find f of A. You've got to find these two pieces so you can sub that into your IROC formula. And once you sub those in to your formula, that formula goes pretty smoothly from there. So you sub those into your formula. Now, remember when you do that, something on top, well, in our case, our number was 0, so it really didn't cancel out necessarily. But when the number is not 0, when you get a constant up there, remember those are going to cancel each other out if you did your algebra right. So once you step those in and cancel that constant term out, you'll be left with all h terms, right? So your next step would be to divide h out of all terms. And once you do that, remember that's the step that gets rid of your denominator. And once you don't have a denominator, you can take the limit. So you take that limit, and remember taking that limit, all it consists of is subbing in 0 for h. So sub 0 for h, anywhere h might be. In our cases, we've only had 1 at the end to sub that in. If you have more than one h there at the end, you would put 0 in for all of them. And you guys, what is this going to give me? It's going to give me the instantaneous rate of change, or the slope of the tangent line. So let's say your answer, yes, it is the instantaneous rate of change, but it's also the slope of that tangent line. And remember that slope is, we use m for slope when we're making the equation for a line. I am taking this out in really small steps. You might have wanted something more general, but here we are. So 7. So you guys, all of this to find the slope. I promise it'll get faster from here. So step 7, use m and the point found in, let's see, what step did we find the point in? We found it here. So in step 2, to find the line equation. I don't know how, I think that's about as many steps as, well, I could say this. I could say to solve for b. Let's say that. So let's use m and the point that we found by doing f of a to solve for b. And remember, why do we need b? Because we're using y equals mx plus b. We're actually using a point slope form, but we've derived it from this formula. So let me finish these steps and we'll talk about that. So we solve for b. You guys, once you have b, you just put all your value, you put m and b into here, and then you have your line. Okay, so I got a question. Why do we have to find instantaneous rate of change though we have do you mean average? We have average rate of change? Yes, okay, so it is less accurate. So average rate of change, it does a similar thing. You're finding the slope of a line, but that line, so you pick average rate of change, you pick 2 points, and it has to be 2 separate points. And that's the problem, because we can draw a line between these 2 points, and then we have some error. Now, there doesn't look like there's a lot of error on this one, but remember, a lot of times there is. So the difference in instantaneous rate of change is that we don't have to pick 2 points. We figured out a way by using limits to be able to look at the change at 1 point. And the smaller your interval, so in this case, instantaneous, the more accurate the change is at that specific point. So yeah, I could say, well, the average rate of change between these 2 points is the slope of this line, but there's a lot of difference going here. And remember, as your interval gets closer together, your change gets more and more accurate. So what we've done is we've taken that limit. Now we're looking at the change at one specific point. So there's no interval anymore. The interval is what brings error. At this one specific point, there is no error. That is exactly moving at that pace at that point. The problem being, if you move a little bit off of that point, it's not accurate anymore. But like I said, we're gonna get past that. We're gonna find a way to make instantaneous rate of change work for all points on a graph. But yeah, so that's why we have to find it. It's just more accurate, or it's perfectly accurate is what it is. Okay, so that's a lot of steps there. I think I spent a lot of steps on the IROC stuff, but I think that's the new stuff, right? So of course, we're gonna have to work on that. And you guys, the biggest thing I'm gonna tell you, whether it's homework, a quiz, exam, whatever, don't mess up your algebra here. That's the place. That's gonna get you if you're not careful. So yeah, guys, like I said, it's kind of short today. That's all I got for you. Oh, speaking of quizzes, we need to have one. So don't get scared. But I want to have a quiz. Now our quizzes are online, so we're not going to have them in class. But what I want to do is through this point. So from 11.1 to 11.4. No. I will figure, I think this is still 3. I will let you know for sure. But to this point where you can find instantaneous rate of change and possibly find the slope or equation of a tangent line, from the beginning to this point today, I want to open up a quiz this weekend. When I say this weekend, I'll probably open it up Friday, like after class, or maybe I'll probably do it in the morning because whatever. So I'll open up Friday morning and it'll be open through Sunday. So you have days to take it. And you guys, you'll just go on to MathLab. It should be under assignments or however MathLab works. It works differently on my end. But it's not going to be very long. It's our first quiz. It'll maybe be probably between 6 and 8 questions, you know, nothing crazy. But it means that if you're not on MathLab yet, you need to get on MathLab because you'll miss your quiz. And I will set it to be due on Sunday night, just like that first, this first section of homework is due. But just keep that in mind. Yes, you're going to have Friday, Saturday, and Sunday to take it. Just as far as being prepared, make sure that you have good notes over this stuff, because if you have notes, you can use notes. You know, I don't mind that at all. There's not much I can say other than I highly discourage you using outside resources because, I mean, really, you're at home, right? I can't see you. And there are some programs that are supposed to cut down on stuff like that, but honestly, they don't. The results aren't any better. So I'm just trusting you guys. You guys, it only hurts you, right? If you, you know, if you use outside stuff to get answers, because it means you still don't know how to find the answer. So just keep that in mind, just being honest. I know most of you are, but I will talk more about that in class in person on Friday. So, so yeah, I will see you guys face to face, or like this, face to face on Friday, if you guys don't have any other questions.
No, I'm good. Thank you.
All right, cool. I will see you guys later.
I have one quick question.
Oh, yeah, go ahead.
It goes back pretty early in the problem where you plugged in x for a as x approaches 1. And then in the next spot, you put that into the formula. You put f of 1 plus h equals the formula 3 times 1 plus h squared and all that. So why did we take why instead of it just being the function of x, why did we put the function of 1 plus h equals blah, blah, blah?
Okay, so
That's kind of hard going off of Word.
I think I know what you mean. So let me get some space. So the 1 plus h, that's built into our IROC formula. So remember that formula is the limit as h approaches 0. On top, this is f of 1, or sorry, it's not, it's a. For us, it was 1. So that's the formula. it has this A plus H in there. So when we
Right.
put a 1 in there, it became 1 plus H. So that's standard. Like no matter what your A is, you're always going to be finding this term here. And in our case, it was 1 plus H. So if A was 2, we'd be finding F of 2 plus H, or and so
Right.
on.
I follow you there. It's what's the process, or why did we take that first term and put it on the left side of the equal sign?
That was just so we could find it. So if I need F of A plus H, I have to put it into my function for, right? So our function, let's do the one. So I think what you might be getting confused about is, so I starred this because it was side work. Does that help? So we're doing this, but I have to find this before I can plug it in. So this is side work. This is just me finding F of 1 plus H. It's not part of my work in this formula as far as steps down go. So what did I do? I did 3 times 1 plus H squared. So I did that. And we found that, right? It ended up being this. What did I do with this? This is what I plugged in here. So in the formula, I have to put F of A plus H here. But before I can do that, I have to find out what it is. I actually have to put A plus H into the original function and calculate. So then I can take this, and instead of just writing F of A plus H, I actually put the whole thing there. This is F of A plus H. So now I can replace it here. And then remember the F of A, that was just finding the F of 1. And in our case, on this one, it was 0. So I had this here, and then it was minus 0 over H. You can't work the problem if this function notation is written up here. So I can't do algebra on the term F of A. I can find F of A and get that number that it equals, and then I can put that up there, and then I can continue working the problem. Just the same with this. I can't leave it as F of A plus H. I actually have to find F of A plus H by sticking A plus H into the function and then finding an expression. And that expression is what goes here.
I see what you're doing now. It wasn't the whole problem. You were taking that one piece of it and then working that and then plugging that piece back into it. Okay, I'm tracking you now. Thank you.
Okay. Cool. All right, any other questions, guys? Are we all good? All right, well, I will see you guys on Friday then.